whenever you want. So here, okay, we are going to look into this alkane. Okay, alkane, we have to remember about free radical substitution. So if you have, okay, this one is wrong. Okay, if you have single bond, okay, carbon-carbon single bond, so you are going to have, okay, the free radical substitution. Okay, this free radical substitution will happen one by one until all the hydrogen is fully replaced. So it depends on how we want to write it down. So in this case, I'm going to just substitute the hydrogen that I show over here with this Cl. So the product will be always HCl. Okay, the product will be an hydrogen hydrogen halide. Okay, so it must happen under UV light and sunlight. Okay, so here, okay, what are the steps? Okay, we have 3 steps. Initiation. So if I want to write down, it's going to be Cl2 with the presence of UV light and sunlight. Homolytic fission is going to happen to give you 2 Cl dot. Okay, free radicals. Free radical is a species that has 1 unpaired electron. So propagation, what are the propagation? So I'm going to write it as CH3, CH3. Okay, so CH3, CH3. When I react with free radical, so I am going to remove over here. So it's going to be CH2. I put a dot over there, and then CH3. Then you have HCl. Okay, so here I'm going to get a free radical and neutral. So next is going to be the free radical that you have formed. They will join with a neutral molecule to give you CH2Cl CH3, which is this molecule. Okay, and then you are going to create another free radical. Okay, that's it according to this question. And then for termination, you can just write down free radical plus free radical to give you Cl2. Or you can write down CH2, CH3. When I join with another free radical of Cl, I'm going to get CH2, Cl, CH3. Okay, so this is going to be all the steps involved. Now, the next part is going to be related to alkene. Okay, carbon-carbon double bond, which we call it as unsaturated hydrocarbon. Unsaturated hydrocarbon, they are very reactive. So they are going to be, because of the presence of the pi bond, okay, the double bond, they are rich in electron. Therefore, electrophiles, okay, they are attracted towards the pi bond. Okay, so we have what we call as electrophilic addition. So we have 4 types of electrophilic addition, okay, which is addition with H2, addition with Br2Cl2 or I2, addition with HBr, HCl, HI, and addition with steam. Okay, so all of them, they have their conditions. Okay, the conditions for H2 is going to be nickel catalyst with 140 degrees Celsius. Br2 halogen, okay, aqueous and room temperature. HBr, hydrogen halide, will be concentrated and as well as room temperature. And then addition with steam is supposed to be concentrated phosphoric acid, 330 degrees Celsius, 6 megapascal. Okay, if you want to change it into atmospheric pressure, then it's going to be 60 atm. Okay, but according to your syllabus, 6 megapascal. Okay, now hydrocarbons, okay, therefore you can separate them. Okay, like you can see that these 2 molecules, okay, they look like non-polar. So I'll just put it together, the mechanism. And then these 2, they are polar molecules. So I'll put it the mechanism like this. So overall, you can see when we are trying to draw the mechanism, there are two main mechanisms. Okay, so it means even though they look similar, basically they are similar. Okay, but when they ask you, like for example, when you have alkene reacting with Br and Br2, okay, how do I represent this using curly arrow diagram? So we know Br2 is going to be non-polar. Okay, so the non-polar, how do we represent? The concept is this non-polar molecule, when they come closer towards, okay, this one I think I'm not going to use arrow. Okay, so like for example, when they come closer, okay, when they come, okay, generally you get the idea. Basically, when Br2, when they go closer to the carbon-carbon double bond, what happens is they have electron, and Br2 also have electron. The electron and electron, they will repel. okay, when that repels, okay, what happens is you are going to have the electron move to one side. Okay, that is going to create the delta negative and delta positive, partial negative, partial negative. But the difference is the heterolytic fission will not happen yet. Okay, will not happen yet. So what happens next is going to be automatically straight away this one. Okay, the double bond. Okay, so do remember it's a movement of electron. So the electron will move from here to that. And then only you are going to have CC, the Br, okay, they will come over here, and then this will create a carbocation, okay, plus, and then you have all this, and you are going to have the Br, okay, negative dot and dot, and now what's going to happen, this one will come over here, and to give you C, Br, and Br. Okay, so this is going to happen. Quite simple. Okay, curly arrow diagram. Okay, but if let's say, for example, if I want to show for HBr or for example H2O, okay, how do I show? It's going to be, they do not need to come near to carbon-carbon double bond. Okay, they just need to because they are polar. Okay, automatically the Br is more electronegative. They will become delta negative, delta positive. So what happens is going to be you are automatically getting H plus, heterolytic fission will happen. So Br minus, you have this already. Okay. So what's going to happen next? Automatically this one will come here. So CCH, and then you have, okay, this one will become positive. And then you have Br minus over there. So what's going to happen? This one will come here. And then you will have, okay, this is H, this is Br, done. Okay, this is what we call as by using the curly arrow diagram. Okay, movement of electrons. Okay, very simple. Okay, just simple as that. But okay, this for this part, okay, we need to be very careful because sometimes you will have a situation where you can have more than one product. Okay, so in that sense, okay, which one do we select? Like for example, if I have CH3 and I have CH3 and then I have H, I have H. So if I try to react with HBr, for example, so where do the H and the Br will go? Are you going to get CH, H over here, then CH3, CH3, Br over here, or are we going to get the CC? Are we going to get H over here, Br over here? Because these two are different. So in order to do to identify whether which one will be formed, okay, of the major product, so we need to remember, okay, the concept of Markovnikov rule. Okay, this Markovnikov rule say that if you have more R groups, okay, the carbocation that has the more R groups, they are more stable. Okay, they are more stable, and then they will be formed more because more positive inductive effect. But how to apply? Okay, how to apply? Okay, just remember the hydrogen will always go to the carbon that has the most hydrogen directly attached to. So you see the carbon, 0 hydrogen directly attached. The carbon here, 2 hydrogen directly attached. So the hydrogen will come to this carbon. So this hydrogen will come here, and then this molecule will be the major product. Okay, why? If they ask you why, then you explain. Okay, because they are going to form CH3, and this is plus before the Br comes in. And then if you are drawing this one, then it's going to be CH3. If the H comes here, this is going to be the positive. So if you look at the, type of carbocation, okay, you can see this is going to be tertiary carbocation. And if you look over here, this is going to be only primary carbocation. So tertiary carbocation is more stable than primary carbocation. Therefore, okay, it can confirm that this is going to be the major product. So this one you need to be careful also. Yeah, that's it for today.